Now it's recording. I reached in for my pocket now. Oh, there's the memory stick. So for maximum power transfer, RL has to equal R Thevenin. And once we have that, to get how much power, to answer question number 2, we find the voltage here. Since these guys are equal, it'll be half that number. We divide, square it. So the amount of power here is going to be the voltage. It's V Thevenin divided by 2, square it, divided by R sub L, which end up what? V Thevenin squared over what? 4 RL. Why is the voltage divided by 2? Because these are equal. If they are equal, the voltage will split in half. So half the voltage will be here. Half of that number will be here. And power is V squared divided by R. And that's what I use here. So now let me go ahead, chop the circuit right there. And find the Thevenin equivalent for that. What I don't like about this is I get that delta connection. I did that on purpose, actually. That delta connection, I can change it to Y connection, which will be one resistor down, split into 2 ways. So I can take this and replace it with something like this. And let me find what these values are. And once we have them, my circuit will look a little bit easier. So let's do that. So this is minus to plus 9 volts. That's 11. I think I said 11 last time, right? Yep. This is the 2. Now watch what's going to happen. This is going to look like this. And this is actually will be V Thevenin, which is V open circuit. And the question, what are the values for these? Let's call this R1, R2, R3. I need to find what they are. Now, I saved my sheet here. And I said, if you have a delta connection like this, that's the purple, remember that? And you want to change it to Y, to find this resistor, that one, you multiply the 2 adjacent one, and you divide by the sum of them. If you want to find that resistor, that's R sub Y, you multiply these 2 adjacent ones, R1, R sub 3, that's what goes on the top, divided by the sum of them. If you want to find R sub Z, you multiply these 2, and you divide by the sum of them. So here, R1 is the top one. I'm looking at that picture, both pictures. So R1, you're going to multiply the 2 resistors around it, 10 and 12. Divided by the sum of them, 10, 12, and 22. 32, is that 44? So that's 120 over 44. Right? 10, 22, and 12? Yep. This is 2.72. Now to find R sub 2, that's this resistor. I'm going to multiply 12 times 22 divided by 44. So that's 264 over 44. That's a 6. And I got to find R sub 3, which is that resistor. It's going to be 10 times 22 over 44. 220 over 44. And that's 5. So I can redraw my circle a bit nicer because it looks ugly right now with the bends and all that in it. So let me redraw it nicely. This is R sub 2 here. What was R sub 2? What was the value of that? 6? I should have left some room for me on the top. Okay. Let me redo it with some room. I didn't leave any room for me. This is 6. What was R sub 3? R sub 3 is 5. There's the 1. And there's R sub 1, which is I think 2.72, right? Can we simplify anything? Notice all the stuff I learned before, I can still use it. What does that mean? I can do source transformation here.
Oh, you can also do 5 plus 1.
Yep, I will do that.
Okay.
Source transformation will give me a current source with a value pointing down of what? 9 divided by 11. In parallel with the 2, the 11. I should put the 11 next to it first, but I already wrote the 2 there. Boy. There's the 6. And the 5 and 1 is what? 6? 2.72. Little bending here and there. I took these two, combined them into one, that's a 6. I took these two, that's this and this. The 6, I just put it this way and I connected it right here. Now, these guys in parallel, product over the sum. 22 over what? 22 over 13. And I dropped actually the 2 point, well, let me put it back there. 2.72. I dropped it first and I put it back in. I changed my mind. How come I dropped it first and I put it back in? I'm going to drop it eventually. Why? It's an open circuit. What's the current going through it? 0. The voltage drop here is what? 0. So this is not even there. So my circuit really looks like and if you want to do source transformation again, you can do source transformation. And the value for the source will be, oh, I forgot to put what here? 22 over 13. And the value of that source will be what? 9 over 11 times 22 over 13. By 11, this is 2. 2 times 9, that's 18 over 13. Maybe I'll use a calculator for these numbers. 18 divided by 13. So I have a voltage source of a value of 1.38. I can combine these two resistors together. 22 divided by 13 plus the 6, 7.69. 6. And what's V open circuit or V Thevenin? Do we have it? V Thevenin equals V open circuit, which is 1.38 times 6 over the sum of these two. 6 and 7 is what, 13.69? I get 0.6. The voltage 0.6 volts.
Where'd you get the 13.69?
This plus this.
That plus that, okay.
So that's V Thevenin. Now I need R Thevenin. Remember, I need to find the V Thevenin and R Thevenin for Thevenin equivalent. Here's the good news. Let me go back a couple of pictures back. It really doesn't matter where I look at it, but let me go back right here. When I was right here. Any one of these. What kind of a source do you have here? Dependent, independent, or what? Independent. So what does that mean? To find R Thevenin, when you only have independent sources, what do? You kill all the sources. You only use this method if you only have independent sources. How do you kill them? Voltage source becomes what? Short circuit. Current source becomes what? Becomes open circuit. Huh? Yeah, they have a few things there, but not a lot. Yeah. But the way you kill the sources, if it's a voltage source, you make it a short circuit. If it's a current source, you make it an open circuit. And you could have both of them there. So you kill them all. In this case, there's only one source. And if I grab the picture here, because it's kind of simplified, why redo everything? So if we take that picture and kill that source, that becomes an open circuit. Like this. Notice I'm putting that resistor back because I'm not looking for the voltage. I'm looking for R equivalent, R Thevenin. That's what R Thevenin. If you look back that way, what is R equivalent? EQ stands for equivalent in my handwritten notation there. So we know this piece is useless. How are these two connected? The current's going to come. There's only one way to go. So these two resistors are connected in series. Because that piece that you see here, I can just take my white out. Go, this is open. I don't need it. Here we go. That's what you have. Now, how are they connected? Definitely in series. So the equivalent of them is going to be the sum of them. So let's go ahead and add them. 6 plus 22 divided by 13. 7.69. Now these two, how are they connected? Parallel. The product over the sum. Product over the sum. 6 times 7.69 divided by 7.69 plus 6 in parentheses. 3.37. Product over the sum. And these two, how are they connected? In series, so you add them. What's R Thevenin? Now, if my numbers are right, it says 6.1. Bless you. So we have 6.1 ohm R Thevenin. So my circuit right now, one little boo-boo here. This value should have been what? I just looked at it. Minus on the top, plus on the bottom. Right? So V open circuit, I defined that plus on the top, minus on the bottom. So it really should be minus here. To indicate it's going to be minus to plus. It's not going to be plus to minus, you know? Because this current is going to force it to go this way. When you have a source with a negative sign, it goes through it this way. So it's going to mark it, so this will be a minus here. The value is going to be 0.6, but it should be minus to plus, not plus to minus when you put it there. So if you want to put plus to minus, you have to write negative 0.6. If you make it minus to plus, will be 0.6. So my V Thevenin here, if I want to go correct direction, it should be minus to plus 0.6, or I can reverse it, plus to minus negative 0.6, either way. This is the 6.1. And this is R sub L, and you want R sub L to be 6.1. Or again, if you don't like that, if you like the plus on the top, the minus on the bottom, that's fine. Negative 0.6. 6.1. R sub L equals 6.1. So no change. It just minus on the top, because your source was minus on the top, plus on the bottom. That's going to push it in that direction. Or plus minus, that'll be a negative 0.6. So this is R sub L. Now, what is the maximum power transfer? How much power is being shipped to that load? So the power, let's find the voltage across the load. The voltage is going to be half of that number. So the voltage across the load is going to be negative 0.6 divided by 2, which is what? Negative 0.3. If you mark it plus to minus. This is VL. Plus to minus on the top. So VL is negative 0.3. So what is the power delivered to the load? It's the voltage across the load squared divided by the resistor of the load. This is negative 0.3 squared divided by the resistor of the load, which is 6.1. And that's 0.015 or 15 milliwatts. So the power delivered to the load is 15 milliwatts. I chose this problem because I wanted to review multiple things. I wanted to review maximum power transfer. I wanted to do delta to Y because we didn't really do that many of that. And I wanted to do Thevenin. So this problem has everything in it. And I even did source transformation in it. So I managed to cover a lot of stuff in one problem.
I think that's what I was most confused
Yep.
with. Source
Yeah, you can actually mix and match. Just because it says Thevenin, that doesn't mean you can't still use other techniques.
Mhm.
Let me pick another one now, quickly, maybe with Thevenin, and I'll mix and match what's in it. Okay, here's an ugly one. Determine RL for maximum power transfer. That's an indirect way of saying find R Thevenin. Here's my circuit. 0.9 amp, 900 milliamp, which is 0.9 amp. If I say find R sub L for maximum power transfer, I'm not saying what's the power. You'll need to find R Thevenin, that's it. But we'll do both here. And this is 0.1 VAB. $50, $20, minus the plus, 2 VAB, $10, and this were VAB. And there's R sub L attached right at the end of that. So the circuit is chopped here. I say, what value of R sub L can we attach here? That'll give me a maximum power transfer. That's R sub L.
So is maximum power transfer hours like related to R sub L?
R sub L has to give maximum power transfer to the load. You need R sub L to equal R Thevenin. So you'll never be given with R sub L. You got to find it, which has to be R Thevenin. So I got to Thevenize my circuit. I got to take my circuit and cut it right there. And Thevenize it. But notice this circuit has what? Independent and dependent. So we have both. And dependent sources. Since you got both of them, to find R Thevenin, it's not going to be kill the sources. Doesn't work here. Killing the source only work when you have only independent sources. R Thevenin is going to be V open circuit over I short circuit. So which one you want to find first? You choose, doesn't matter, one of these two. We need to find V open circuit, then we need to find I short circuit. And it's just a matter of preference, which one you want to find first.
Will you be open circuit first?
Okay. V open circuit.
Basically, it doesn't matter as long as you just have to do them both. It doesn't really matter what order you do.
Nope. So I'm going to open that circuit. Watch what I'm going to do to make my life a little bit easy. Look at my circuit now. 0.9 amp. Here's the 100. Look what I'm putting next to it. The 50. I took this, put it next to it. They're all in parallel. I don't really care which one you put. Doesn't make any difference. And this is your VAB, which happens to be what? That's V Thevenin, or V open circuit. So VAB is V Thevenin, V open circuit, all of them. I can take these two resistors in parallel, the product over the sum. 50 times 100 divided by 150. 33.3. Point 9. 33.3 ohms. Point 1. I'm going to write that instead of VAB, V open circuit. Because VAB equals V Thevenin equals V open circuit. 20 minus to plus 2 V open circuit. 100 or 10, I'm sorry, not 100. And this voltage here is V open circuit. And now we're going to solve for V open circuit. Well, if I do one more source transformation, I'll have two loops I can do, and it'll be two equations by two unknowns. So let's do a source transformation. Oh, that current source becomes what? Source transformation. The name source, we're going to change the source. Plus to minus. Notice the tip, the arrow is the plus, the tail is the minus. 0.9 times 33.3. This will be 30 volts. This is 33.3. This is 0.1 V open circuit. 20. 2 V open circuit. 10, and this is V open circuit. Now we can do mesh analysis. We can assign current going this way, we'll call it I sub 1. We can assign current going this way, we'll call it I sub 2. We write two equations by two unknown. Solve for I sub 2. If you know I sub 2, you know V open circuit. 10 times that number. So my V open circuit, it's 10 times I sub 2. So if I know what I sub 2 is, I am done.
We don't need to know I sub. Oh, okay.
So we have two unknowns, I sub 1 and I sub 2. Can we do an equation right here, mesh equation? Can we do one here?
No,
Why not?
because you have the 0.1 VOC.
That's a current source. I don't know what the voltage there. Can I do one here?
Yes.
Try again. Can I do one here?
No.
No, current source. You have no voltage here. You don't know what the voltage. Not zero. We have no idea. So it looks to me, the only path I can take, it looks to me, if I take the outside. If I go this way. That's the only path. Can you see it?
Yeah.
That's the only way I can go. Outside. So let's do an equation on the outside and see what will happen. Minus 30. Plus what? 33.3 times what? I1 plus 20 times what? I sub 2. This will be minus 2 times what? VOC. 2 times what's VOC equal to?
You don't.
10 I sub 2. It's written under it, right? VOC is 10 times I sub 2. Otherwise, you're going to have three unknowns in that equation. Plus what? What's the voltage here? 10 I sub 2. Move the 30 to that side. That's 30 equals what? 33 I sub 1. 20 I sub 2 minus 20 I sub 2, they're gone, right? Plus 10 I sub 2. That's equation number 1. Where's equation number 2 going to come from? This current source in the middle. That's correct, David. Point 1, V open circuit, the current pointing upward. Since it's pointing upward, has to be what? I sub 2 minus I sub 1. Point 1, what's V open circuit? That's 10 I sub 2. What's 0.1 times 10? Just I sub 2? Guess what that means? What is I sub 1? I sub 1 is 0. If I sub 1 is 0, guess what V open circuit is? We don't know what V open circuit yet, right? Why? Because that's 10 times I sub 2. Till I know what I sub 2, I can't do it. So let me come back here before I answer this. Let me find what I sub 2 is then. From this equation, 0 plus 10 I sub 2 is equal to 30. What's I sub 2 equal to? 3 amps? Going back to that equation, V open circuit equals 10 I sub 2, which means 10 times 3, and that is 30 volts. That's the first part. I'm getting nervous, the video is getting too long now. I short circuit. Let's put a wire at the end there and see what will happen. Putting the wire actually is a blessing for us. Let's look at that circuit, the one above it. I don't know if you can, no, you can't see it. Here we go. Put a wire here. What will happen? VAB, that's what they call it, VAB, earlier. 20, I don't want to call it V open circuit, there is no open circuit here. It was 2 VAB. 10, and this is VAB right here, right? But now you're going to stick a wire here. And when you stick a wire, what happens to VAB? What's the voltage right here when you have a wire there? 0. If this is 0, guess what happens here? That's 0. Guess what happens here? That's 0. I'm looking for the current down. I short circuit coming down. Guess what happened to that resistor? That's gone. A resistor in parallel with the wire. The wire is 0. 0 times 10 is 0 divided by 10, which is 0. So that resistor is gone. So now my circuit looks like this. Current source gone, that means open circuit. It looks like this. 20. A voltage source is gone, that's short circuit, gone. This is gone. And this is I short circuit. The current's going to travel this way. So Ohm's law says I short circuit, or the current through that's going to be the voltage source is 30 divided by what? 53.3. The sum of them. 53.3. So 30 divided by 53.3 equals. And that's what? 0.56. Done with the I short circuit. Can I find what R Thevenin is? It's V open circuit over I short circuit. What's my V open circuit? 30 divided by 0.56.
Is this one more problem?
I don't think so. It's back of the chapter. 53.3. This happens to be the same thing, 30 and 30. So that resistor will have to be 53.3. So the Thevenin equivalent for that,
Wait, just gotta finish reading. Yes, I just got it. Thanks.
the Thevenin equivalent, old stuff. We said that's 30 volts, V Thevenin, 53.3. That means R sub L has to be what? Has to be 53.3 for maximum power transfer. What's the voltage here then? Isn't that half of this number? When the resistors are equal, voltage division. It's going to be half the number. So what is the power delivered to the load? Is the voltage squared divided by that resistor. 225 over 53.3.
15 squared is the voltage divided by 2, right? And then squared.
Well, this voltage is 15 because it's half this number. I already divided. So this will be 4.2 watts.
The answer is 2.2 watts.
Watts in this case, yeah.